Are there any questions over any of the assignments so far? If not, we're going to be looking at completing the square again today. Now, completing the square had four main steps. One is a equal to 0. If not, make it so. 2. Get the variables on one side and the constant terms on the other. Our third step was to find C, which is equal to B over 2 squared, and plug in. Step 4 was to factor and solve. And really when we talk about factoring, we're just rewriting our quadratic into a set of parentheses squared. Rewriting our perfect square trinomial as a binomial squared. Well, trinomial, tri means 3, because perfect square trinomial, 3-termed polynomial function. A square, a binomial squared, binomial, a 2-term that's being squared. All right. Anybody still copying these down? Now this here is the first problem we're going to look at. Now we've looked at this problem already. X squared minus 16x plus 64 is equal to 100. Now, the way we did this yesterday is we said, okay, x squared minus 16x plus 64 is a perfect square trinomial. Really, we didn't say that. I went on and just factored it, and we saw that it was. Let's just say we didn't see that. That we didn't see that this here x squared minus 16x plus 64 is a perfect square trinomial. And we went on and started completing the square. Well, the first step in completing the square is a equal to 1. Yes, because a is the number in front of x squared, and it is 1. So we can move on to step 2, which is get the variables on one side, and the constant term, the numbers without a variable on the other. So for here, that means I would subtract 64 from both sides. Now 64 minus 64 would cancel, telling us that we have x squared minus 16x plus blank is equal to plus, because again, we're going to be putting that C value back in. Now for finding the value of C, I always do that work off to the side so that we do have space to continue on with the problem. Now C, our third step, is equal to b over 2 squared because we're going to plug it back in both of these spots here. Now the b value in our case is? Well, negative 16 divided by 2 is negative 8. Yeah, because negative 16 divided by 2, 16 divided by 2 would be negative 8. And negative 8 squared is 64. So we would add 64 both here and here. Yep. Here, this would reduce to x, what? Because what goes inside with x is inside the parentheses before we square it, so it'd be x 8 squared is equal to, wait a minute, what did we start out with? So will it still work and we get to the same place if we didn't realize it was a perfect square trinomial? Well, yes, it'll still work. But the steps we did to get there, essentially, we undid it and then redid it back over. But it'll still get us to the same spot. Now that we have it as a set of parentheses squared, we can square root both sides, which will tell me that I have x minus 8 is equal to plus or minus 10. We can add 8 to both sides, which tells me x is equal to 8 plus or minus 10. Can we add 8 and 10 or subtract 8 and 10? Yes. So we do need to do that. We need to say that x is equal to 8 plus 10, or x is equal to 8 minus 10. Well, 8 plus 10 is, and 8 minus 10 is. And those are our two answers. Could we have found this solution by graphing? Well, yes, we could have subtracted the 100 over, graphed it, and solved. Because if we set it equal to 0 and graphed it, hey, we do have two whole number answers. We can find them. Now, on the graph, negative 2 will probably show up pretty easily. And if this was the graphing calculator, let's see here, yep, it would come down here at about negative 2 and do something like this here. It might be a little bit lower, but this was what it would look like on the graph. Because the standard coordinates for the graph that pop up are from negative 10 to 10, negative 10 to 10 on both the x and y. So would the x value of 18 show up? Well, no, because 18 is bigger than positive 10. It wouldn't show up. But we do know that it is a quadratic, yes? And all quadratics are a U-shape, yes? So that means if the graph is coming down this way, what is this going to have to do? If it's a U-shape, it's going to have to go back up somewhere on the right-hand side of the graph, yes? So that means if I pull up the table and I keep going down, I should see it eventually, the y value stop decreasing and start increasing until it hits a 0. Questions on this here? Any other questions on these here? I want to move on from this one here for one main reason. What do we notice, or what do we think is going to happen with x squared plus 6 or minus 6x plus 9? Well, that's a perfect square trinomial. And it's not because there's a 1 on the other side. Because our b, the c value that we need would be b over 2 squared, yes? Well, what's the value of b here? Well, negative 6 divided by 2 is, and negative 3 squared is 9. So it's not that there's anything wrong with this. We can still do the same properties and operations. I want to look at some that are 100% completing the square, where we're not utilizing the steps of completing the square and essentially rewriting the first step over and ending up back at the same problem we started with. Here, 8 is not going to be the C value we need for this to be a perfect square trinomial. It's just not. Now, is A 1? Yes. Okay. We're going to subtract 8 from both sides. And what this will give us is x squared minus 4x plus blank is equal to negative 8 plus blank. Now, I will tell you all right out, if I was not given a method to solve this, if I was not told specifically to solve this by completing the square, I would graph it first, or I would try factoring first. Because factoring and graphing, I think at this point y'all feel more comfortable with that. It's easy to see the factors and work it out. If we can do that faster, I always try it first and see before doing this here. Now, okay, now it's going to work out. Graphing probably won't give us good answers. Factoring definitely won't. So we'll have to use this here. So we moved the 8 over. Now we need to find the value of C. Now C is equal to B over 2 squared, and the value of B is? Well, negative 4 divided by 2 is? And negative 2 squared is? 4. So here we would have 4, here we would have 4, yes? Our set of parentheses squared, we're going to have x, and the number that goes with x is? So that means x squared minus 4x plus 4 factors down to x minus 2 squared. Now on the other side we have negative 8 plus 4, which is? Okay, this definitely would not work for graphing, because what's our next step? Because we're going to start solving, so we need to take the square root of both sides. So here the square root and square would, leaving us with x minus 2 is equal to plus or minus 2i. Because the square root of negative 4, well, the negative would come out as I, and the square root of 4 is 2. Well, if I have I as any part of the solution, will it cross the x-axis? No, these are no real solutions that we found with graphing. So graphing is immediately out. This also tells me that there's no way I could factor it, because when we factor, we need real numbers. We would need those. Now we can get it back to a factored form once we get the answers, but there's no way to go straight from a factoring this to these here. It's easier to go from the answer with imaginary or complex or imaginary answers or radical or our irrational solutions back to factored form. But we do have one last thing we would add 2 to both sides. Shows me x is equal to 2 plus or minus 2i. Now that's it, because we cannot add 2 and 2i or 2 minus 2i. We cannot combine that together because 2 is a real number. 2i is an imaginary number. We cannot combine those. And that's it. Questions on this here? How do we feel about these here? We want to look at another one. Yes? No? Do we feel comfortable with this kind of problem here? Because we're still going to look at more, but they're going to be a little bit different. So we feel good, Reagan? Okay. Let's look at this one here. What makes this problem different than the ones we've done thus far? Right, the number in front of x squared is not 1, yes? So the first step whenever we're doing this here, we could see, is this factorable? If I was not directly told to do this by completing the square, and just told to solve, I would try graphing. I would try factoring. I might not write it all the way out with factoring. I would just try it in my head to see if I could do factors of 3 and 15 to get to 12, which here it might work out. But also if I'm given whole numbers, well, it means that it could factor to begin with, and I could get it by graphing. However, if it tells me solve this by completing the square, okay, we're going to have to complete the square. So if we're having to do this by completing the square, I'm going to rewrite it first. On the test, you don't have to rewrite it. You can go on straight into step number 1. I just wanted to rewrite it so that we do have it outside of that words, solve, and everything else. Now the first step in completing the square was what? Is a equal to 1? Well, it's not. If not, make it so. So how can I make the number in front of a squared, or x squared, be 1? Divide everything by 3. Divide everything by 3. Well, 3x squared divided by 3 is x squared, exactly what we wanted. 1x squared plus this will not factor. Because since the third term is positive and the sign, so the signs are going to be the same and they match the sign of the middle term. So I need 2 factors of 5 that add together to be 4. Well, the only factors of 5 are what? 1 and 1 plus 5 is? 1 plus 5 is? 6. Okay, that's not going to work. Because the only way that we can have a constant term bigger than the middle term is if we're either adding or subtracting. It's got to go down. Okay, most likely it won't factor. Okay, second step in completing the square is to get the variables on one side, constant terms on the other. So we would subtract 5 from both sides, which would leave us with x squared plus 4x plus blank is equal to negative 5 plus blank. Step number 3 was to find what? C. C is our what over what? B over 2, which in this case would be positive 4 over 2 squared. Positive 4 divided by 2 is? 2 squared is? X squared plus 4x plus 4 will factor to what? Squared is equal to? Negative 1. What do we need to do next? Square root both sides. Need plus or minus. What is the square root of negative 1? Because by definition, the square root of negative 1 is I. So, okay, well, we can definitely tell at this point here it would not graph and it would not factor. And what do we need to do lastly? That's it. What do we think about this here? We feel good with this here? Do we need to see another example where A is not 1? Okay. Okay. Do we feel good with this here? Okay. I was looking back at this. I threw another problem in at the end because, I mean, these are all well and good, but they're not, I hate phrasing it this way because it's just showing that I'm a little different than most. These here aren't fun. So I added this one in. And there is a key difference to this one than the previous. And we'll see it here in a second. Because if we work through this one here, I can tell you right now, we're going to do this by completing the square, so we won't look at factoring or graphing. So the first step in completing the square is A equal to 1. Well, no, so we have to do what? So we have to divide every single term by 2. Well, 2x squared divided by 2 is x squared, exactly what we wanted, yes? Well, what's the next one? For completing the square, because I'm all for decimals because they do work better in most cases than fractions because they're a little bit easier to work with. But here, at some point, we're going to have to take the square root of both sides, yes? Square roots and decimals are harder to work with. Square roots and fractions actually work easier. They're better to work with. So we're going to leave this as fractions since it doesn't divide evenly. And I'm showing you this here because we could have skipped over this and been just fine. But this here is one of the biggest drawbacks to completing the square. Because if we have an A different than 1, and every single term is not divisible by that A, it gets a little funky. It doesn't get more difficult. We just have to deal with fractions. Well, our next step is to get the variables on one side and the constant terms on the other. So the steps aren't going to change. We're just now dealing with fractions. Here we'll have x squared minus 5/2 x plus blank is equal to negative 67/2 plus blank. Has this gotten any real harder than the last ones? No, it's just the numbers are weirder, yes? Well, c is equal to b over 2 squared. Well, what's the value of b? So we have negative 5/2 divided by 2. Which would be negative 5/4. And that's how we can do that there. A lot of the times when I see this here and I'm working with it, and the reason when I say I have that times 5 with the test is because, okay, I look at that saying, since we're dividing just by 2, I'll flip it in my head, multiply by the denominator, and we get the number. Now when we square it, well, since it's negative, it's going to come out as positive. 5 squared is 25. 4 squared is. So we're adding 25/16 to both sides. Now we have to factor x squared minus 5/2 x plus 25/16. We're going to have to figure out the factors of 25/16, yes? What number goes inside there? As we said, the number inside those parentheses before we square is going to be what goes inside here, negative 5/4. It gave it to us because negative 5/4 squared, we already saw, is 25/16. And it has to be the same number in both. Now the only tedious calculations we have to have is negative 67/2 plus 25/16. Unless your college professor decides to be ridiculously mean and remove all calculators, it would be mean, but you'd have to do some of the stuff by hand. Otherwise, we can go on and type it into a calculator and get the answer. And if we do this here, we should get negative 511 over 16. Yes? And I did this problem earlier today. That's why I know this number. Because really all we're doing is changing negative 67/2 into 16ths. So we'd multiply the numerator and denominator by 8 and then combine and subtract our numerators. $536 plus 25. Yeah, so that would be right. We just needed to add it to the 25/16 to get to our final answer. Any other questions on this here? Now, our next step would be the square root of both sides. Well, here the square root and square would cancel out, leaving us with x is equal to, well, okay. Well, here, I'll go on and write it out, because normally I would do this off to the side. What we can say is that we have, according to our square root properties, I can split it up. Instead of just having the square root of that entire fraction, we can have the square root of the numerator over the square root of the denominator. Exactly. Well, the square root of 16 is, the negative with 511 would come out as I. Now we can grab the other calculator and say square root of 511. And it tells us that it's actually 511. Because 511 is not divisible by 2. It's not divisible by 3 because 5 plus 1 plus 1, if we add the digits together, which is 7, is 7 divisible by 3? No, then the number itself won't be either. 4 is, we just have to plug it in. 511 divided by 4 is 127.75. It's not divisible. 5 isn't divisible because it doesn't end in a 0 or 5. 6 doesn't work because 2 and 3 don't work. 7 we can try. 7 and 73. Well, 7 and 73 are 7's prime. 73 doesn't have any real factors besides 7. And it works out, it's just square root of 511. Still need to get x by itself, so we would add 5/4 to both sides, which tells me x is equal to 4ths plus or minus I square root of 511 over 4. wait a minute, the denominators are both of these are the same, aren't they? We can write it as 1 or we can write it as 2. Either one works just fine. Questions on this here? Any questions on anything we've covered so far today? Let's see where this shows up. So that there is completing the square, and that's what we can do for it there. Now, as I said at the beginning of this chapter and throughout it, there's 2 methods that will work every single time. Completing the square is one. The other one that we will cover tomorrow is the quadratic formula. The quadratic formula is the other method that will work every single time. But that is all we're going to cover today. Now, at the start of the chapter, or start of the lesson tomorrow, the first thing we're going to actually look at is seeing how completing the square will actually give us the quadratic formula. It will give it to us.